If I ask you to find the area of this rectangle, you could probably find it pretty easily by multiplying the length by the width. Similarly, you could probably find the area of this triangle by multiplying the base and the height and dividing it by 2. Now what about this shape? Even though it's more complex, you could just break it up into rectangles and triangles and find the area of the entire shape by adding the area of each individual rectangle and triangle. By now, you're probably feeling pretty confident on how to solve these. So what if I ask you to find the area of this shape? You could again just break it up into triangles and rectangles, but that would take far too long. That's where the Shoelace theorem comes into play. Hello everyone, and welcome to a different perspective. This lesson will be on the Shoelace theorem, a stupidly powerful but very easy to learn tool that you can use in geometry, especially in analytical geometry. This theorem allows us to calculate the area of any polygon, assuming that we know the coordinates of all the polygon's vertices. A polygon is any shape with three or more sides, all of which are straight. So this semicircle, this circle, and this ellipse, for example, are not considered polygons. Basically, any shape with a curved side is not considered a polygon. So now, let's get into how to apply this theorem to an actual polygon. If I have this shape with these vertices, the first thing I'm going to do is choose any of these points to be my starting point. It doesn't matter which one you choose, but I'll choose the point 3, 5 to be my starting point for this example. Make a x and y table and input your starting point at the start of the chart. Next, we have to choose our second point. Each subsequent point chosen after the starting point must be adjacent to the previous point. So I can choose the point 1, 3 or the point 7, 2. But I cannot choose these 2 points as it is not adjacent or connected to the previous point. For this example, I will choose the point 7, 2 to be my second point and then input it into my table. Now we just repeat this pattern and input all the points into the table in order. Once you've input all the points, write your starting point at the very bottom of the table again. Your starting point should be present at the very top and at the very bottom of the table. By now, you will be done with the shape and only need to focus on the table. Take the top left number, or the first x coordinate, and multiply by the number that is diagonally downwards from it. Since 3 times 2 equals 6, we'll just jot that down on the side here. Repeat this pattern for all the x values. Next, multiply the top right number, or the first y coordinate, by the number that is diagonally downwards from it, or the second x coordinate. 5 times 7 is 35, so again, I'll just jot that down on the side here. This pattern is then repeated for all the y coordinates. As a fun fact, the diagonal lines you see here kind of looks like a shoelace, which is where the name of the theorem comes from. You can also use the imagery to help you remember how to do the theorem. Anyways, we then find the sum of all the products in this column and jot it down. Do this for the other column as well. Now for the final step, find the difference of these two sums and then take the absolute value of that difference and divide it by 2. That will be your final answer, which is the area of this polygon. Anyways, that will conclude this lesson, and I'll see you in the next one.